This is George Sicalius, and this is Sprint 6. Okay, um, so like last week, my tank can hug the terrain. Also now my enemies can also, they use the same script to correct their rotation matrix, so they can also hug the terrain. I also started playing around with the, well, upgrading the enemy's AI. So I decoupled the base and the turret, so the turret can move independently from the AI. As of right now, it's still pretty buggy. Um, and yeah, I've also been trying to take into account bullet drop for the AI's aiming. But I was unsuccessful this week in getting something that worked relatively well. So yeah, that's where I'm at. Um, so for the collision stuff, um, so for first things first, I made a asset manager for the terrain. It's pretty much the same thing like the other asset managers. You pass in a string and then the various variables that you want to assign to the given terrain, such as the length, the height map to use, the texture. Um, so yeah, and yeah, I do it right here. So this is where I'm loading in my terrains in resource loader. Um, so right now I just have two terrains. Yeah. Um, so then to actually assign a terrain to a scene will then call set terrain. And this is a method in the scene which essentially tells the scene manager, whose responsibility is to keep track of the current scene, terrain manager. It'll set that the current terrain to the terrain passed in. So I have another terrain manager that's scene level. And yeah, this just stores the current terrain that's being used for the scene. Um, Let me pull that up really quick. Terrain test management, terrain manager. So yeah, it's pretty similar to the camera manager. It's pretty bare bones, but yeah, it doesn't really have a whole lot to do. So for the actual collision stuff, so the way I have it set up, an object has to register to set collision terrain to actually collide with the terrain. So this will just use the given terrain script, which is terrain command, collision command, which is inside collidable right here. Okay. And so yeah, it's essentially doing everything it did from last week. Take the terrain, compare it with the take the terrain, get the given object to compare it with, and then get the rectangle representing the cells that are touching that object, and then iterate through that, and then do additional tests to make sure to see if it's actually colliding with any of the specific cells for that terrain. So yeah, so terrain rectangle. Let me pull that up. Terrain rectangle. No, cancel. I'm not sure if you're okay with this setup, but I have the iterator be a subclass of the terrain rectangle. So an iterator of terrain rectangle is inside of its subclass, similar to how STL does a lot of their iterators. So yeah, so terrain rectangle, it stores its minimum cell data, its maximum cell data, and just a pointer back to the terrain for fixing references and stuff in the iterator. Um, and then I just have two methods, begin and end, which return iterators corresponding to these specific cell data's min and max. The iterator, so yeah, it stores its current cell. I guess that's a little bit redundant, storing its. Oh no no no. So yeah, it stores its min and max IJs, which are then used when iterating through the rectangle. So actually looking at the iteration, so that's just setting it. Okay, yeah, right here. Okay, so if it's when post increment is called on the iterator, it'll just update its I, and then reset its I. So yeah, that's that case. If it's at the end of the given rectangle, if it's at the last cell, last I cell, then it'll move down 1J and then reset its I. So that's what's happening right there. And so yeah, I think that's it. As I mentioned, I started experimenting with updating the enemy AI to take into account the bullet drop when shooting. So where is that? So yeah, I'll have to dig up some old physics notes just to get that a working formula for that. But this is what I came up with so far. As of right now, it doesn't work properly, but yeah, it's some progress.